All right, so this is going to be kind of a review of inverse trig functions, talking specifically about why we restrict the domain, and then how to apply that when we're doing composite functions. So, and then there will be a quiz tomorrow again, through the 2.6 through 2.9, I think. Okay. So, just a quick review. If I have, let me just do this. The sine function, which goes also over here. And it goes on forever, right? Sine. Okay. So the thing that you have to remember when you find the inverse of functions, we figured that out in the very first section in 2.6. To find the inverse of functions, you just switch x and y, right? And then solve for y. But for the inverse of a function to also be a function, the original function has to pass a horizontal line test. Okay? Remember, to find whether this function is a function, we do vertical line tests, and as long as the line only goes through at one point all the way around, then we know it's a function. So sine of x is a function. But if I want to know whether this function is considered one-to-one, which means it's a function and its inverse is a function, then I run a horizontal line test through. And you can see when I run a horizontal line test through the sine function as it goes on forever, it's going to be connecting at multiple points to infinity as it goes left and right. Okay, so it is not a one-to-one function. Well, for us to use the inverse, it must be a function. So what mathematicians did is they said, what can we do to force it into a one-to-one function? So they restrict the domain. Okay? And so for the sine function, what they do is they start here, and they go here, and this is the only piece of the sine function that we worry about when we find the inverse. Okay? So the domain is restricted for sine from negative pi over 2 to pi over 2. Okay? It's just this little piece. They could have picked any piece along the sine function to restrict. But the mathematicians of the world, apparently, I don't know when, 100 years ago, got together and said, we're going to choose negative pi over 2 to pi over 2. And that's the area we're going to restrict. Because if you look at this piece, I could also use this piece, and I could use this piece, and I could use any little piece. But this piece specifically passes the horizontal line test and the vertical line test. So it's a function, and its inverse is going to be a function, as long as I just deal with that piece. Okay, on the unit circle, that means it's only in these two quadrants that we care about for sine. Why this is important. If I want to know the inverse sine of 3 pi over 4. Well, hopefully you learned in the next section, take the inverse sine of sine, and it's just what's left. Right? So your answer then would be 3 pi over 4. And it would be wrong. Because 3 pi over 4 is not in the first and fourth quadrant. And it has to be, for the inverse sine function, it has to be restricted to just the values in that quadrant, those two quadrants. Okay, so what you have to do when you see a problem like this is you want to ask yourself where, because remember this is, sine of 3 pi over 4 is what value? Do you remember? What's 3 pi over 4 as a reference angle? Meaning first quadrant angle. What would it be? 3 pi over 4 is a reference angle. If I draw my triangle here, what's this angle? 45. Pi over 4. Right? This is 4 pi over 4. If I go back to 3 pi over 4, I've gone back pi over 4. So pi over 4 is my reference angle. Okay? So I'm really asking, sine of 3 pi over 4 is what? In a fraction. Do you remember? What's the sine of 45? root
Yeah.
over 2. Root 2 over 2. Remember this? Okay? Okay, root 2 over 2. So, and is it positive or negative? Positive. So what you need to do in a question like this is ask yourself, given the domain restriction, okay, quadrant 1 or quadrant 4, which quadrant will give me the exact same value for sine and which angle in that quadrant that I just got? Root 2 over 2. Is it positive? It's positive, so it's got to be first quadrant. What angle in the first quadrant will give me the exact same value for sine of 3 pi over 4? Say it. Pi over 4.
Yeah.
Pi over 4. Right? They're equivalent. Sine of 3 pi over 4 and sine of pi over 4 are equivalent. The difference is sine of pi, or pi over 4 is in that domain restriction. Okay? So the answer here is pi over 4. Okay? So anytime you're looking for a composite, this is a composite function because it's a function inside of a function. Okay? The rules apply that if it were, if I had sine of pi over 6, well then it's just pi over 6. But you have to ask yourself that underlying question of, is this angle in the domain restriction? If it is, pi over 6 is your answer. If it's not, then you've got to find an equivalent angle that's in that restriction that will give you the same value and match your answer. Okay? So who can tell me the domain restriction for cosine? 0 to pi. 0 to pi. Okay, so let's just draw cosine real quick so I can show you why. I'm not going to be quite as one period of the cosine graph. Okay, what they decided to do is restrict it at pi. So there's the piece of the cosine curve that we can take the inverse of. Okay, for cosine then, on the unit circle, it can be in quadrants 1 or 2, from 0 to pi. Okay, so if I give you a problem, cosine of, it's a 7 pi over 6. Well, don't just jump to it and say 7 pi over 6 is your answer. Where is 7 pi over 6? Third quadrant. What's the reference angle? What's that angle? 30 degrees. Pi over 6 is your reference angle. Is cosine positive or negative here in the third quadrant? Negative. So which quadrant, 1 or 2, is it also negative?
2.
2. So our actual answer here is what? You can do it. 5 pi over 6. Okay, so the answer to this question is 5 pi over 6, because at 5 pi over 6, cosine is the same value. You follow? Okay, this is why we restrict the domain, and then why our composite functions your logic has to go in this way. Okay, domain restriction for tangent. You remember? Negative pi over 2 to pi over 2, same as sine. Same as sine. Okay, so let me give you this one. I have to come up with one here.
And it's a 5.
Uh-huh. Inverse tangent of cosine of 5 pi over 4. So what do you do on the problem like this when it's not just inverse tangent of tangent? No calculator.
No, like.
Calculate it.
Yeah.
So where do you start? Cosine of 5 pi over 4. So what quadrant is that? Third. And what's the reference angle? Pi over 4. What's cosine of pi over 4 in the third quadrant? Root 2 over 2. Negative, though, because it's the third quadrant. So now I'm doing inverse tangent of what? Is that what I do? No. Yeah. Inverse tangent of. So where's tangent square root of 2 over 2? It's not going to be one of your special angles, is it? Because tangent's never, like 45 degrees. I'm trying to think if I could have used a better example here. Probably could have. What if I did, well, I mean, this one you'd have to use a calculator. So you have to find inverse tangent of negative 0.707 or whatever it is. And it's not going to be one of your special angles. So I want to do something different. I got to think of a better problem. Let's do this. Let's just change it to sine. I changed it from tangent to sine. You found it?
Yeah.
Nice.
It was right there.
Okay, thank you. I changed it from tangent to sine. What's the answer here? Stretching your brains. Well, ask yourself first, what quadrant does it have to be in? First or fourth? Fourth quadrant. So now what is the answer? Right? What is that? Angle without using a negative. 7 pi over 4. Mm-hmm. Okay. It technically can be negative square root of 2 over 2 here, but that's not in the domain restriction for sine. So this is your only answer. Following the logic?
Yeah, okay, now I see it.
Okay. All right, so everybody kind of understand domain restriction and how to find composite functions of trig functions? Okay. All right, so I'll let you spend the rest of the period then finishing up web work and CK12 for section 2.9.